Welcome everyone. This is Ashok, Assistant Professor, Haldia Institute of Technology. So today I will discuss about the differential equation. So before that we need to know what is dependent variables and independent variables. So for examples, consider the growth of a tree. Growth of a tree, suppose it depends on the amount of rain and amounts of light. So here growth of a tree is a dependent variable. It depends on the amount of rain and amount of light. So these are independent variable. So dependent variable means that depends on other variables. Okay, so in generally dependent variables is denoted by y and independent variables is denoted by either by x or t. Okay, so look here, dy by dx. What is the meaning of that dy by dx? Here dy by dx means the rate of change of the dependent variable y with respect to the independent variable x, and this is the second order derivatives with respect to x, and this is nth order derivative dny dxn. So all these terms you know are called differential terms. Okay, so now let's come to the point. What is ordinary differential? When the number of independent variables is only one, then the differential equation is called ordinary differential equation. But if the number of independent variables is more than one, then the differential equation is called partial differential equation. So what is ordinary differential equation? Look here, any relation between an independent variables x, a dependent variable y, and one or more of the differential terms is called an ordinary differential equation. That means any relation between these dependent variables, independent variables, and any differential terms is called ordinary differential equation. So look here, dy by dx plus x square y equal to 0. So this is a ordinary differential equation. This is the differential terms. That is x square is the independent variables and y is the dependent variable. Okay, so this is a differential equation. Similarly, this is also a ordinary differential equation. Ordinary differential equation because here the number of independent variable is only one. Here x is the independent variable and y is the dependent variable. Now look, y equal to x square. Is it a differential equation? No, this is not a differential equation because there is no differential term, there is no that type of terms. So this is not a differential equation, this is a equation. Now look, dy by dx equal to 0. Is it a differential equation? Yes, this is a differential equation. Here dy by dx is the differential terms, y is dependent variable and x is independent variables. So this is a differential equation. Now we will study what is the order and degree of a differential equation. So look here, order, it is the order of the highest order derivative involved in the differential equation. So that means order is the highest time derivatives, that is the order. So for example, look here, d2y dx square whole cube plus 3x dy by dx whole to the power 7 equal to x cube y into d2y dx square to the power 4. So for this differential equation, this is the first order derivatives, this is second order derivatives, and this is also second order derivatives. So that means here maximum number of differentiation is done is 2. So that means the order of this differential equation is 2. So the order of this differential equation equal to 2. Okay. Now degree. Highest power of the highest order derivatives after removing fractions, that is after making the differential equation in a polynomial form. So what is the meaning of that? Highest power of the highest order derivatives. That means you have to first find the highest order derivatives, then you have to find the maximum power of this highest order derivatives. For example, look for this example. Here the highest order differential term is d2y dx square. its power is 3, and here highest order differential term is d2y dx square, its power is 4. So among 3 and 4 maximum power is 4, so the degree of this differential equation is 4. So degree of this differential equation equal to 4. So now look here, 1 plus dy by dx whole to the power 3 by 2 equal to d2y dx square to the power 7. So what is the order of this differential equation? Means you have to find the highest differential terms. Look here, this is first order derivatives, this is second order derivative, that means the order of this differential equation is 2. So now you have to find what is the degree of this differential equation. Look here, you may say the degree of this differential equation is 7, but look in the definition, after removing fractions, highest power of the highest order derivatives after removing fractions, means if there is any fraction, then you have to remove this fraction first. Look here 3 by 2 is a fraction, so you have to remove this 3 by 2. How to remove this fraction? Take square in both side. So take square in both side. Okay, so you will find 1 plus dy by dx, this 2 and 2 will cancel out, so 1 plus dy by dx whole cube equal to d2y dx square to the power 14. So that means that now the highest power of this highest order differential term is 14. So the degree of this differential equation is 14. Okay, now look here for this differential equation, y equal to x dy by dx plus 7 dx by dy. So look here dy by dx and dx by dy, there are two type of differential terms. So you have to first convert this differential equation into one type, means either dy by dx or dx by dy. So I convert this dx by dy into dy by dx. So look here, equal to x dy by dx plus 7 by dx by dy, here dy by dx. So dx by dy equal to 1 by dy by dx. Okay, so now simplify this. If you simplify this dy by dx, y into dy by dx equal to x into dy by dx square plus 7. So now look, for this differential equation, the highest time derivative is 1, means this is the first order derivatives and this is also first order derivatives. So clearly the order of this differential equation is 1. So order of this differential equation equal to 1. Now for degree, think what is the highest power of the first order differential terms. So this, the power of here is 1 and the power of dy by dx here is 2. So that means the degree is 2, because between 1 and 2 is maximum, so degree is 2. Now check the order and degree for this differential equation. Suppose for example 1, d2y dx square whole square plus sin dy by dx equal to 0. So clearly here this is the second time derivatives present here and this is the highest order differential terms. So that means the order of this differential equation is 2. Now degree. So you may say the power of this highest order differential terms is 2. So that means the degree of this differential equation 2. But not, this is not correct. So look here the definition of degree. Highest power of the highest order derivatives after removing fractions, that is after making the differential equation in a polynomial form. So what is polynomial form? Polynomial form means it contains a finite number of terms, or more clearly you can say a polynomial is an expression that can have constants, variables and exponents, that is powers, but never division by a variable. A polynomial can have any finite number of terms but not infinite, and this is the general form of a polynomial. That means a polynomial can have finite number of terms and also there never be any division by a variables. So for example, suppose here 7x. So 7x, this is an expression having constant 7 and variable x. So this is a polynomial. Okay, there is no division by another variable, so this is a polynomial. And x plus 2, this is also polynomial. Y square minus 2x, this is also a polynomial. Y plus 7 by 9 x square, this is also a polynomial. 7 by 9 is not a variable, it is constant, so this is also a polynomial. And simply 7, the constant 7, this is also a polynomial. Now look for this example, 7x by y square. This is not a polynomial because 7x is divided by the variable y square. So in polynomial there is no division by a variable, so this is not a polynomial. 1 by x plus 2, this is also not a polynomial. 1 by x, this is also not a polynomial, and root x, this is also not a polynomial. After making the differential equation in a polynomial form, but here sin dy by dx, this sin dy by dx, there is infinite number of terms if you break this sin dy by dx, because the series sin x equal to x minus x cube by factorial 3 plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial and so on. So this is an infinite series. So if you break this sin dy by dx using this formula, then here is the infinite number of terms. So that means the order of this the degree of this differential equation is not defined, because this violates the definition. So for thus the order of this differential equation is 2 and degree not defined. Okay, so degree of this differential equation is not defined. Similarly, e to the power d2y dx square plus cos x dy by dx equal to 2. So look here, if you break this expression using this e to the power x equal to 1 plus x square by factorial 2 x cube by factorial 3 and so on, so you will get infinite number of terms here. So the degree of this differential equation is not defined, but the order of this differential equation is 2. This is the highest order differential terms, second order. So the order of this differential equation is 2, but degree not defined. Similarly, log d2y by dx square plus dy by dx, the order of this differential equation is 2, but degree is not defined because there is infinite number of terms within this expression. If you break log x, then you will get infinite number of terms. So but for degree, that expression must have finite number of terms. So in this way, this is not the degree of this differential equation is not defined, but the order of this differential equation is 3. Okay, so if there is any terms containing like this sin dy by dx, cos dy by dx, e to the power dy by dx, log dy by dx, sin d2y by dx square, in this way. So in this way, if there is any terms containing that type of expression, then degree is not defined. Okay, thank you.